Despite having a bad reputation as a high risk factor for cardiovascular diseases, cholesterol is an essential component of all animal cells. It is an integral part of the cell membrane, providing membrane fluidity and participating in a number of cellular processes. Cholesterol also serves as a precursor for production of bile, steroid hormones, and vitamin D. While the body can obtain cholesterol from food, many cells synthesize their own endogenous cholesterol. Cellular production of cholesterol is under negative feedback control. Low levels of intracellular cholesterol induce its own production, while high cholesterol levels inhibit it. Cholesterol, together with other lipids, is transported in blood plasma within large particles known as lipoproteins. A lipoprotein is an assembly of lipids and proteins. Lipoproteins are classified based on their density. Because lipids are lighter than proteins, particles that contain more lipids are larger in size but have a lower density. Different types of lipoproteins have different sets of proteins on their surface. These proteins serve as address tags determining the destination and hence function of each lipoprotein. For example, low-density lipoprotein, LDL, carries cholesterol from the liver to other tissues, while high-density lipoprotein, HDL, returns excess cholesterol to the liver. Major events in cholesterol metabolism include dietary cholesterol is absorbed in the intestine and carried via blood circulation to the liver. The liver packages its cholesterol pool, a combination of endogenous and dietary, together with triglycerides, another type of lipid, into particles of very low-density lipoprotein, VLDL. VLDL travels in the bloodstream to other organs. During circulation, muscle and adipose tissues extract triglycerides from VLDL, turning it into low-density lipoprotein, LDL. Peripheral cells take up LDL by endocytosis using LDL receptors. Cholesterol is used in cell membrane and other functions. Excess cholesterol is exported from the cells and delivered to high-density lipoprotein, HDL, to be returned to the liver in a process called reverse cholesterol transport. The liver uses cholesterol to produce bile. Bile is secreted to the intestine, where it helps break down fats. Part of this bile is excreted in feces. The rest is recycled back to the liver. LDL has the highest cholesterol content and is the major carrier of cholesterol in the blood. High levels of LDL in the blood are associated with cholesterol plaque buildup and cardiovascular diseases such as heart attacks and strokes. For this reason, LDL is known as bad cholesterol. On the other hand, HDL is called good cholesterol because it removes excess cholesterol from tissues and the bloodstream. Common drugs used to lower cholesterol include inhibitors of endogenous cholesterol production, inhibitors of intestinal cholesterol absorption, and inhibitors of bile reuptake. Despite having a bad reputation as a high risk factor for cardiovascular diseases, cholesterol is an essential component of all animal cells. It is an integral part of the cell membrane, providing membrane fluidity and participating in a number of cellular processes. Cholesterol also serves as a precursor for production of bile, steroid hormones, and vitamin D. While the body can obtain cholesterol from food, many cells synthesize their own endogenous cholesterol. Cellular production of cholesterol is under negative feedback control. Low levels of intracellular cholesterol induce its own production, while high cholesterol levels inhibit it. Cholesterol, together with other lipids, is transported in blood plasma within large particles known as lipoproteins. A lipoprotein is an assembly of lipids and proteins. Lipoproteins are classified based on their density. Because lipids are lighter than proteins, particles that contain more lipids are larger in size but have a lower density. Different types of lipoproteins have different sets of proteins on their surface. These proteins serve as address tags determining the destination and hence function of each lipoprotein. For example, low-density lipoprotein, LDL, carries cholesterol from the liver to other tissues, while high-density lipoprotein, HDL, returns excess cholesterol to the liver. Major events in cholesterol metabolism include dietary cholesterol is absorbed in the intestine and carried via blood circulation to the liver. The liver packages its cholesterol pool, a combination of endogenous and dietary, together with triglycerides, another type of lipid, into particles of very low-density lipoprotein, VLDL. VLDL travels in the bloodstream to other organs. During circulation, muscle and adipose tissues extract triglycerides from VLDL, turning it into low-density lipoprotein, LDL. Peripheral cells take up LDL by endocytosis using LDL receptors. Cholesterol is used in cell membrane and other functions. Excess cholesterol is exported from the cells and delivered to high-density lipoprotein, HDL, to be returned to the liver in a process called reverse cholesterol transport. The liver uses cholesterol to produce bile. Bile is secreted to the intestine, where it helps break down fats. Part of this bile is excreted in feces. The rest is recycled back to the liver. LDL has the highest cholesterol content and is the major carrier of cholesterol in the blood. High levels of LDL in the blood are associated with cholesterol plaque buildup and cardiovascular diseases such as heart attacks and strokes. For this reason, LDL is known as bad cholesterol. On the other hand, HDL is called good cholesterol because it removes excess cholesterol from tissues and the bloodstream. Common drugs used to lower cholesterol include inhibitors of endogenous cholesterol production, inhibitors of intestinal cholesterol absorption, and inhibitors of bile reuptake.
Yan, good morning everyone. Good morning. Kamusta ang inyong mga quiz? Okay, so ang tataas ng mga scores ninyo, nag-study yun sila ba?
Sir, lisod lagi kaayo.
Lisod na perfect. Ganit mo? Kanila gina-analyze doon nga na perfect, oh.
Sir!
Anyway, so nga at ang quiz, no, na alam nyo sa atong mga presentation as well as sa inyong mga group mates. Sila ba yan nagtatag quiz ang inyong group mates? Ba ang reporters, Lenny?
Yes, sir. Sir, na-backstage daw iba naming groupmate.
Sige, wait lang. Yan. Sana yun sila. Yan, si Isa Nova. Okay, so, bago tayo mag-start class, mag-check muna ako ng inyong attendance, ha? Pakisulat sa ating comment section ng hashtag MP ako 2020. Yan, so sino ba ang nahirapan sa ating case study? 5 points ba yan ang case study na ito, class? Okay. Sino kaya yung mga nahirapan sa ating case study?
Sir, ano daw si Kay, sir? Na-backstage daw siya.
Kailangan magsayaw. Ay, wala man lang na backstage. Yung nasa backstage ha, kailangan magsayaw muna. Okay. So, wait lang. Wala pa ha. Okay, so, tatawag muna ako ng names class. Balik-balik sa balik. Okay, unya na mag-RMP ako. Wala ko katawag sa inyong name. Okay, so let's start with among kiss. Ian. So, Barida, Batadlan, Benitez, Bulahan, De Viejo, Folio, Gatinaw, Gubat, Humbe, Iway, Lariba, Lisita, Mahilo, Mamades, Mercado, Minyao, Nefi, Odoya City, Safia, Odoya City, Sofyan, Pacquiao, Ramirez, Rilio Robes, Rojero, Ronulo, Siscar, Soberon, Tac-An, Timpomona, Valdez, and Zamora. Okay, so I think halos tanan na ano tayo, no? Isa ang nasa backstage si Donna Hombe. Yan. Okay, nandiyan na si Hombe. Donna, sino ang mag-present sa inyo? Sino mo yung share
Si Donna, sir.
Okay. So, nag-breakfast na ba ang lahat, class? Naka-breakfast na ba? So, kasi ngayong araw na to ay madugo ang ating ilong. Basic questions lang ganito akong ipahatag. Yan. Check natin yung mga scores. Okay, may... Okay naman yung mga scores ninyo, class. Achievable. So, dapat i-continue ang inyong grades, ha? Maski sa finals, dapat the same pa rin. Yan. Sana yung iba.
Sir, na backstage daw
Si
si
Arla.
ano, na si Humbe. Tsaka si Chris.
Wala. Sige na, pasudlan na sila balik. Pasok kayo balik, guys. Yung mga nasa backstage. Si Donna kay on daw ang imuhang mic or cam. Donna, please turn on your mic and cam para makasulod ka. Hindi man ako siya ma-add, okay. Ang device daw niya kay wala daw na-connect iyang mic and camera. Okay. So far, kamusta ang inyong mga quiz? Nakapasa man ang tanan siguro? So, asa man mo nalisdan nga part?
Sir, tong sa ano, Bisal, antibody.
Ano pa lang kung nagpapasa uwan lang. Yan, nakasulod na si Donna. Donna, pakilagay yung... Actually, nakita ninyo yung rationale sa ating case study. Nakita ninyo, Lenny?
Sa sir?
Rationale sa answer. I-check ninyo later. Kasi meron yung rationale doon sa case study. Bakit ganun ang sagot?
Doon ko makita.
So, naanang inyong presentation. Yan. Okay?
Makita po.
Yan. Opo, makita siya. Okay, may nagproblema din sa internet connection, sabi ni Faith. Faith. Benitez.
Sir, backstage daw po si Kay.
Taman siya rin, wala siya nakasulod. Sige lang. Okay, so before we start, may I request Krisha Nova to lead us an opening prayer.
So, God knows, let us pray. And so, Father, Son, and Holy Spirit, Amen. Our Father in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our sins as we forgive those who sin against us. Do not bring us to death, but deliver us from evil. Amen.
Okay, amen. Okay, good morning everyone. Okay, class, before we start, class, no, pakisulat muna dyan sa ating comment section, no, hashtag lipids and lipoproteins. Yan, and lipoproteins. Lipids and lipoproteins. Okay, because our topic for today is all about lipids and lipoproteins. Okay, so, saan na sila? Okay. Sige. Sino ba yung unang reporter natin?
Ako, sir.
Okay, sige. Birahin na. Birahin na. Okay, so, sige, you can start kahit wala pa yung iba ninyong kaklase para hindi ma-consume yung time natin. Kasi mataas-taas din yung discussion ko later. Okay, sige.
Marinig ako.
Opo, marinig ka.
Start na ako, sir. So, good morning again. Our topic for today is lipids. Next. Ayan, okay na. So, what are lipids? Lipids came from the Greek word lipos or lipos, which means, and these are hydrophobic in nature due to predominance of hydrocarbon chains, which are bonded together by nonpolar covalent bond, which is very strong. Therefore, it is rarely dissociated. Kaya siya insoluble in water, but it is soluble in organic solvents. Next po ako. So these are the different forms of our lipids. It can be in a cholesterol form, a fatty acid, a triglyceride, or a phospholipid. Next po. For the functions, lipids serve as a storage form of metabolic fuel. They also provide structural components of membranes, which is important in the stability of cell membranes, and it allows transmembrane transport. Next. So this time we are going to discuss the biologically important groups of lipids. Next po. First is neutral fats, or also known as true fats. These are found in the thigh or torso area of the body as padding and insulation to keep our body warm. So it consists of fatty acids in the form of triglycerides such as oleic, linoleic, stearic, arachidotic, and palmitic. And these are produced after esterification of glycerol with fatty acids. And when you say esterification, it is the process in which fatty acids react with alcohols to form esters and waters, which can produce monoglyceride, diglyceride, or triglyceride. And dito sa ating neutral fats, it is in triglyceride form. So ang kanyang primary function is to store energy in our adipose tissue, which serve as full of readily available fuel. Conjugated lipids, these are esters of fatty acids with alcohol, but it contains extra groups in addition to alcohol and fatty acids. So these are combination of phosphate or sugar groups to lipid molecules. For our phosphate combined with lipid molecules, we have phospholipids, which are phosphate esters, and one characteristic niya is amphipathic lipid molecule siya, which contains both hydrophobic and hydrophilic part, and they are commonly found on the surface of lipid layers for cell wall activity. For our sugar, combined with lipid molecules, we have glycolipids. Babalik ako muna. So yung glycolipids natin, from the word glyco and lipids, these are lipids with carbohydrate attached by a glycosidic covalent bond. And ang primary role niya is to maintain the stability of cell membrane and to facilitate cellular recognition, which is very important sa ating immune response. Next. So ito yun siya yung form ng ating phospholipid. Yung dito sa baba na part is yung hydrophobic tail and sa taas is yung hydrophilic head group which faces the aqueous environment. Next. Next po ako, please. And thank you. Lastly, we have sterols. These are class of lipids containing a common steroid core with hydrocarbon, side chain, and alcohol group. So these are constituent of hormones and other metabolites such as steroid, and ang most commonly encountered is ang cholesterol, which are found in the membranes. Next. So major lipids found in our plasma are triglycerides, cholesterol, phospholipids, and lastly yung lipoproteins. Yung triglycerides natin, from the term itself, it contains 3 fatty acid molecules attached to 1 molecule of glycerol by ester bonds, and it can produce different forms yung fatty acids. Kaya meron tayong mga yung cis and trans fatty acids natin which merong may bend, merong straight lang, and maka-affect yun siya sa properties ng triglyceride lalo na sa kanyang physical properties. And yung triglycerides are classified as neutral fat because it has no charge groups or polar hydrophilic groups, which makes it very hydrophobic and insoluble in water. Yung cholesterol naman natin, these are unsaturated steroid alcohol, which is similar lang sa fatty acid in its physical properties. But yung cholesterol natin, it is amphipathic lipid, which is also found sa surface of the lipid along with phospholipids. But it can also be very hydrophobic if it is in esterified form called cholesterol esters, and it is located at the center of lipid drops or lipoproteins. And ang function ng cholesterol is to promote fat absorption and can act as steroid synthesis precursor. Next is phospholipid, which is na-discuss na kanina. And lastly, yung lipoproteins. And as the name implies, ang lipoproteins are composed of both lipids and proteins called apolipoproteins. And ang main role ng lipoproteins is to deliver fuel to our peripheral cells. Next. So before I proceed to the lipid metabolism, let me just give you a brief background on how lipoproteins such as VLDL, HDL, chylomicrons, and LDL contribute to the lipid metabolism process. Yung chylomicrons natin, these are large lipid transport vessels that carry dietary triglycerides, which are the main oils in our body, throughout the circulatory system to the cells, and ang final destination niya is sa liver as chylomicron remnant. Yung VLDL naman are like tanker trucks carrying triglycerides assembled in the liver to cells for energy and storage. So same lang ang VLDL and chylomicrons. Ang difference lang nila is kung paano sila gamitin ng ating body to produce energy or to store energy. Next is we have LDL, which is rich in cholesterol, and they are nearly empty tankers that deliver peripheral cells and liver after triglycerides have been offloaded. Yung HDL are cleanup crew gathering up excess cholesterol for transport back to the liver. And yung cholesterol natin, these are used by the body to facilitate triglyceride transport, to maintain normal structure and integrity of cell membranes, and precursor for steroid hormone synthesis. but when in excess, it can lead to cardiovascular disease. Next. So, sa lipid metabolism, we have two pathways, the exogenous and endogenous. And unahin muna natin yung exogenous. So, before mangyari yung exogenous pathway, kailangan muna merong lipid absorption na mangyari sa ating intestine. Since fats are water insoluble, kailangan ng special mechanisms to facilitate intestinal absorption. So, this starts off by eating oily or fatty foods, and pagdating niya sa ating small intestine during digestion, yung pancreatic lipase natin, hindi niya ma-access yung fats na yun kasi yung fats kay malalaki masyado yun sila na molecules. Kailangan pa siya i-break down into smaller molecules with the help of bile salts para maging smaller molecules siya called micelles or micelles, so that it can be accessible to pancreatic lipase. And once small molecules na yung fats, yung pancreatic lipase will convert it into free fatty acid, free cholesterol, and glycerol, which can which can be absorbed by our intestinal cells. And kapag nandoon na siya sa intestinal cells, it will recombine yung mga free fatty acid, free cholesterol, and glycerol. It will recombine again to form triglycerides. And yung triglycerides natin, since hydrophobic man siya, it will be repackaged into chylomicrons, which will deliver it into our tissues and our cells. And doon na mag-start ang exogenous pathway. And yung chylomicrons, once na nasa circulation na siya, it comes in contact with lipoprotein lipase, which breaks down the triglyceride inside the chylomicrons para breakdown na yung triglycerides, it can pass through the capillary walls of the blood vessels, and it can be taken up by the tissues and by the cells. And kapag empty na yung chylomicrons, it will now be called as chylomicron remnants. Kaya kung makita ninyo picture sa letter A na picture, mas maliit yung chylomicron remnant kaysa sa chylomicron itself. So, once the fatty acids or triglycerides are offloaded from the chylomicrons, they will now be empty and called as chylomicron remnants, which are bounded to the through the interaction of specific chylomicron receptors na nandito sa liver. Once in the liver, ang chylomicron remnants will be broken down by lysosomal enzymes to release free fatty acids, free cholesterol, and amino acid. So, yun siya ang sa exogenous pathway. Next is ang endogenous pathway. Ay, kaya pala exogenous ang tawag doon sa isa kanina because yung fat is galing sa outside our body, kaya siya exogenous. While dito sa endogenous pathway, ang lipid process is galing lang sa ating body, inside our body. So it involves the liver, but it does not involve the gastrointestinal tract. Kaya wala ng absorption nangyayari dito. So it starts off from previously produced lipids, which are packaged into VLDL particles, which are transported throughout the body to deliver triglycerides. So similar lang ang kanyang fashion doon sa chylomicrons. To go into the circulation, it comes in contact with lipoprotein lipase. It breaks down the triglyceride inside the VLDL, and the free fatty acid, free cholesterol, and the glycerol will pass through the capillary walls and ma-store na siya sa ating tissues or cells as energy. And once the triglycerides has been adequately distributed through the cells and tissues, the VLDL particles will go through a transition to become LDL, which is very poor in triglyceride content but rich in cholesterol. So ideally, these particles are then removed from the circulation by the liver, and the process can start over again. But abnormality occurs kapag konti lang LDL receptors, which leads to decreased hepatic uptake of LDL by the liver and increased ang hepatic cholesterol biosynthesis. And will lead to accumulation of LDL in the plasma, which eventually leads to development of coronary heart disease. Next. So ito na report kay i-present
So,
ni Donna.
Opo.
Thank you.
Next is cholesterol. Cholesterol is a waxy fat-like substance that's found in all cells in your body. Our body needs some cholesterol to make hormones, vitamin D, and substances that help you digest food. So, cholesterol amphifatic lipid is as such essential structures component of membranes where it is important sa maintenance ng correct permeability and fluidity of plasma lipoproteins. Almost exclusively synthesized by animals, but plants do contain other sterols similar in structure to cholesterol. Does not serve as source of fuel, transport and excretion is promoted by estrogen, important constituent of cell membranes, and bile acid kasi ang cholesterol can be converted in the liver to primary bile acids. Ang example niya ay cholic acid and chenodeoxycholic acid to promote fat absorption in the intestine by acting as detergent. Should be measures in all adults 20 years of age, tested at least once every 5 years. It is important na magpa-check when you are young pa kasi since clogging of the arteries is a gradual process that makes many years. Total cholesterol should be measured at least every 5 years starting at age of 20 and more often if you have a family history of high cholesterol. So next picture, nan-synthesize ang chylomicrons tapos isa sa mga components niya ang esterified and esterified cholesterol. So next is the cholesterol reference values. We have the desirable level is less than 200 mg per dl, for the borderline between 200 to 239 mg per dl, and for the high cholesterol is 240 mg per dl. So, yung sa taas, example yan ng mga So, next is for the desirable cholesterol. Considered siya desirable for adults. For the borderline high level, that means your cholesterol level is above normal but not quite in the high range. For the high value naman, high levels of cholesterol can increase your risk of heart disease. With high cholesterol, you can develop fatty deposits in your blood vessels. Eventually, these deposits grow, making it difficult for enough blood to flow through your arteries. So in general, the higher the level, the higher the risk. For the cholesterol diagnostic significance, we have evaluates the risk for atherosclerosis, myocardial, and coronary artery occlusions. Used as thyroid, liver, and renal function test. Used to monitor effectiveness of lifestyle changes and stress management. For the cholesterol forms, I consist of two, the cholesterol ester and the free cholesterol. Cholesterol ester is 70%. Cholesterol bound to fatty acid undergoes esterification by the lecithin cholesterol acetyltransferase or the LCAT. Yung cholesterol acetyltransferase, siya yung enzyme na play a key regulatory role in the intestinal cholesterol absorption and provide core lipid for packaging of chylomicrons and hepatic-derived lipoproteins. For the free cholesterol, 30%, polar non-esterified form of alcohol, siya yung nag-stabilize ng cell membranes.
Okay, so for the methodologies, in testing cholesterol, we use the sample serum and plasma. So, in this test, we measure the total cholesterol. So, sa laboratory, we use the complete cholesterol test or the lipid profile or lipid panel, where it tests the total cholesterol and also the TAG or the triglyceride. And in testing cholesterol, we can also use a non-fasting blood sample for this test. And cholesterol increase with age about 2 mg per dl per year between 50 years old to 60 years old. Because typically, um, men tend to have higher level of cholesterol than women because man cholesterol increase as they age. Women are not immune to increased cholesterol level because they increase in cholesterol during menopausal. Also, cholesterol increases with age as we age because as we age, our liver became less able to remove LDL or the low density lipoprotein or the bad cholesterol. Next. So for our methodologies, for the chemical methods, we use, the principle is dehydration and oxidation of cholesterol to form a colored compound. So first is the Lieberman-Burchard reaction, where in this method or test, it detects cholesterol where where the cholesterol is dehydrated with concentrated sulfuric acid and oxidized with acetic anhydride and also glacial acetic acid that produces green cholestyramine monosulfonic acid that is green in color. And also we have the Salkowski test. Salkowski test. In this test, it is not only specific for cholesterol but may also be used for other sterols, where cholesterol is dehydrated and oxidized with additional of iron salt azide from concentrated sulfuric acid and acetic anhydride to form cholestyramine disulfonic acid that is red in color. And in the Salkowski test is more stable than Lieberman-Burchard. The color is more stable than Lieberman-Burchard. And for the precautions, hemolyzed blood falsely increase cholesterol level. Also, ectoric specimen may increase cholesterol by 5 to 6 milligram or percent in bilirubin above normal. And also, we must avoid water contamination because water may decrease the cholesterol level, and precise and accurate timing for color development must be observed. So next, we have the general methods. First is the single-step method that uses colorimetry. Um, In this method, the colorimetric reaction is performed directly on serum or plasma. Example of the test or method that uses this single-step procedure is the Pearson-Stern and McGavock, where P-thulin sulfonic acid liberates cholesterol from lipoprotein for direct reaction with sulfuric acid in the presence of acetic anhydride and acetic acid. So, Yon. So one step, we use the colorimetry where ang test na nag-use nito is Pearson, Stern and McGavock. Also, we have the two-step method where it uses colorimetry and extraction, where in this method, extraction is introduced, primarily to remove a protein prior to color development. Certain solvent mixture that can dissolve small amount of water and cause proteins to precipitate are necessary for a complete extraction of lipid. Following Following extraction of the lipid, the extracting solvent is evaporated and the color reaction applied to the lipid residue. So the test that uses this two-step method is the Bour's test. Next is the three-step method, where it uses colorimetry, extraction, and saponification. So in this approach, cholesterol and cholesterol ester are extracted, and the latter are hydrolyzed or saponified before color development. Such procedure eliminates interference from protein, and the problem is an equal rate of color development by the free and ester form of cholesterol. The saponification step also tends to destroy some non-specific chromogens. Also, please also the saponification in this method is it used in order to convert cholesterol ester to free cholesterol. And the test that uses this method is the Abel-Kendall test or method. So next is the four-step method. So in this method, we use the colorimetry, extraction, saponification, and precipitation. In these methods are complicated and tedious but reliable. The steps of the procedure are as follows. First is the cholesterol is extracted, then the total cholesterol is then further purified by isolation as the digitonide, where the digitonide is decomposed by saponification, which again frees the cholesterol. Diba, ang saponification sa Abel-Kendall, it used to convert cholesterol ester to free cholesterol. Then, treatment of the free cholesterol with the color reagent to produce the necessary color. By introduction of the digitonine step, the effect of non-specific chromogens is considerably reduced or eliminated. So example of the test or method that uses this four-step method is the Schoenheimer-Sperry Packet and Jung. Parak and Jung rather. So next is the enzymatic method, where it uses the following enzymes: the cholesterol esterase, cholesterol oxidase, and peroxidase. Where in the enzymatic method, the first step is that the hydrolysis of the cholesterol ester by cholesterol esterase, where cholesterol is converted into cholesterol and fatty acid with the use of the enzyme cholesterol esterase. Then next is the oxidation of cholesterol with cholesterol oxidase to form hydrogen peroxide, where in this step, cholesterol is oxidated or added with oxygen. With the use of the cholesterol oxidase, it will form hydrogen peroxide. Then, the third step, oxidation of quinonimine by hydrogen peroxide in peroxidase enzyme, where it catalyzes the reaction to produce the color end product. And then the CDC reference method is the Abel, Levy, and Brody method. Di ba yung Abel-Kendall is doon siya sa three-step procedure where it uses colorimetry, extraction, and saponification. Yan. Then next is Cholesterol is increased when there is hyperlipoproteinemia type 2, 3, and 5, also in biliary cirrhosis, nephrotic syndrome, and poorly controlled diabetes mellitus. And the cholesterol decreased when there is severe hepatocellular disease, malnutrition, severe burns, hyperthyroidism, malabsorption syndrome. So that's all for cholesterol.
So, any question class, no? Sa mga classmates ninyo dyan, baka may mga tanong kayo.
Later, sir.
Classmates ninyo. Bakit saan kaya yung iba, no? Hindi sila nakapasok? Kasi nasa 20 lang tayo ng mga participants.
Sir, pwede po pa-check kay Sir. Siya po mag-report.
Taman siya, wala siya sa backstage.
Ani,
Hindi mo na lang, pakisabi sa kanya na balik dito. And skip muna natin yung triglycerides ba siya
yes, sir.
Triglycerides. So you can see it, no, later na lang natin yan balikan. So hintayin natin siyang makapasok. Okay? Sige, bago tayo mag-move on, no? Ano ang next na reporting? Anong topic?
Lipoprotein, sir.
Lipoproteins. Pakisulat, i-check ko muna yung attendance ninyo, ha. Lipoproteins. Pakisulat sa ating comment section, class, no? Hashtag lipoproteins. Yan. Kasi yung iba, wala sila nagpapaminaw. Okay, naalang sa 20 ka mga ginabilang pa yun ako ang mga nag-participate.
Pakibalik ko sa tribe.
Sino gani yun, ay koan, Lenny? Sino yung
Si
sino
Kay,
gani
sir,
yung
pero
hindi
si Ani
nakapasok?
na lang po mag-report.
Sige.
Sir,
Ano
kanina po siya sige-click sa sir, sa StreamYard. Tapos hindi siya makapasok. Hindi niya alam bakit.
Sige. I-try mo, ha. I-try niya click balik. Sige, okay, kuan na lang, no? Sino yung mag-save the group? Si Annie Rose Mamades.
Hello.
Okay, sige. Yan. Good morning.
Madunggan ko, Len.
Apa.
Hello.
Yes, marinig ka.
Hello.
Yes, oo, just keep going. Namin.
So the next slide is the triglycerides. Triglycerides are a type of fat lipid found in your blood. When you eat, your body converts any calories it doesn't need to use right away into triglycerides. The triglycerides are stored in your fat cells. Later, hormones release triglycerides for energy between meals. So it is also known as triacylglycerol, and the fasting requirement is 12 to 14 hours. Next ko doon. Pa-next po. Next pa doon. So, the normal value of triglycerides is less than 150 mg per dl, and the borderline of high triglycerides is 150 to 199 mg per dl. So, ang reference value ng triglycerides kay kung taas ang triglycerides kay 200 to 499 mg per dl,
And kung masyadong mataas siya, kay greater than 500 mg per dl. Next po. So this is the high triglycerides diet chart. Next ko doon. Next po. So the diagnostic significance of triglycerides is that it evaluates the suspected arteriosclerosis and measures the body's ability to metabolize fat. Next po. So the methodologies. Triglyceride test for triglycerides measures the amount of triglycerides in your blood. So since sa blood man siya, ang sample na kailangan is plasma or serum. Postural changes decrease TAG levels by almost 50%. So ang postural change maka-influensya sa concentration of many analytes in blood, especially macromolecules. It affects the cholesterol concentration by producing shift in the plasma volume, kaya siya mag-decrease. Triglycerides increase at a rate of 2 mg per dl per year between 50 to 60 years old. So, after 20 years old, mag-rapid ang increase ng triglycerides, especially sa females. So, mas prone man ang may edad na 50 to 60 years old, mas prone man sila sa heart attack. So, mag-increase ang kanilang triglycerides ng 2 mg per dl per year. Fasting triglycerides greater than or equal 200 mg per dl are at risk for coronary heart artery disease because of atherogenic VLDL remnants. So, ang fasting triglycerides na may greater than or equal 200 mg per dl kay ginanaro ang fasting triglycerides na may greater than or equal 200 mg per dl kay naganaro ng arteries with the build-up of fatty plaques that lead to heart disease. So ang normal na fasting triglycerides is less than 100 mg per dl. Next ko. So the chemical methods. For the colorimetric method, it is a technique used to determine analytes through comparing color changes of the solution. So, ang Van Handel and Silversmith, nag-extract siya ng serum lipids with false reagent, which is the mixture of chloroform ethanol, and removal of phospholipids with an absorbent, which is the zeolite and alumina of fluorosil. Triglycerides are then saponized with alcoholic KOH, which results in the hydrolysis of triglycerols to glycerol and fatty acids. Glycerol is then oxidized when periodic acid to produce formaldehyde, which is then treated with sulfuric acid solution of chromotropic acid to form blue-colored compound. So, ang result ng Van Handel and Silversmith is blue. So, ang sa colorimetric method din kay naga-base din siya sa CDC reference method. Sa fluorimetric method. Under sa fluorometric method is the Hans diacetyl 1 4 hydrolutidine, and yellow fluorescent compound with maximal absorbance of 412 nm. The lutidine derivative, which forms fluorescence, forms the basis of fluorometric procedure, especially suitable for automated analysis. Ang enzymatic method is under sa kanya kay ang glycerol kinase method. This method uses hydrazine, which complexes the DHAP to shift the equilibrium strongly to the right, driving the reaction to completion. The decrease in absorbance of 340 nm is equal to the amount of glycerol present in the specimen. Other enzymatic methods generate hydrogen peroxide from glycerol 3-phosphate by using L-glycerol phosphate oxidase. So, next ko doon. So, mag-increase ang triglycerides due to hyperlipoproteinemia types 1, LIB, 3, 4, and 5. Also sa alcoholism, nephrotic syndrome, hypothyroidism, and pancreatitis. Mag-decrease naman ang TAG due to malabsorption syndrome, hyperthyroidism, malnutrition, and brain infarction. So, that's all. Next.
Hi guys! Marinig ako? Hello? Hello?
Yes, marinig ka.
Okay, so, thank you. So, good morning everyone. So, we will proceed to lipoprotein. So, when we talk about lipoproteins, guys, we have two different pathways. One thing that we need to understand deeply is the lipid pathways, which was discussed kanina by Asia. So, first, we have the exogenous pathway. Ito yung we actually transport cholesterol and triglycerides and different types of lipids sa tissues ng ating body. Those cholesterols or yung mga lipid sources are coming from our diet. Yun yung exogenous. While the endogenous pathway, yun yung mga cholesterols and other lipids na gisynthesize ng ating body and that gina-transport siya sa different tissues. So, recap lang yan siya, the exogenous and the endogenous pathway. So, when we talk about lipoproteins, ito yung chylomicrons, VLDL, LDL, IDL, and HDL. So, this lipoprotein metabolism is very complicated siya na topic, but I will just explain to you yung simplest and most important information. Pero kung gusto niyo yung in-depth na explanation, pwede kayong mag-watch doon sa Ninja Nerd lecture sa YouTube. It's very informative at saka well-explained yung concepts. Pero 1-hour video yun siya, share ko lang. So, moving on, let's define first lipoproteins. Lipoproteins are molecules that combine water-insoluble dietary lipids and water-soluble proteins. So that lipids can be transported throughout our body. So yun yung lipoproteins. So these lipoproteins, guys, consist of esterified and esterified na cholesterol, which was mentioned earlier, also triglycerides, phospholipids, and apolipoprotein. So, I know we already have a background about these lipids and lipoproteins, but still makinig pa rin kayo kasi mag-question ako. So, first is the, next please. Sige lang, next lang. Next. Yan. So first is the chylomicrons. Yan. They are the largest. Always remember? Yan. They are the largest lipoproteins. And as you can see in the picture, tingnan nyo guys, because of their low density, chylomicrons will float to the top. and form a creamy layer when plasma is stored overnight. They have a density of less than 0.95 kg per liter. So they are formed in the intestines and they transport triglycerides after a meal to the liver, muscles, and fat depot, giving a serum a turbid appearance. So always remember, they are formed in the intestines. Chylomicrons have apoproteins or apolipoproteins B48 mainly and lesser amount ng A1, C1, C2, and C3. Okay? So, in normal lipid metabolism, chylomicrons nag-enter sa ating circulation and metabolize the remnant particles for uptake and further modification by the liver. Pamute muna ako. Okay, thank you. So, as what I have said earlier, guys, if you want to have more knowledge regarding sa detailed lipoprotein metabolism, watch the video. So, doon nyo malaman bakit doon galing ang bakit sa intestine galing ang chylomicrons, ganyan. Next. Next is the VLDL or the very low density lipoprotein. So this VLDL carries endogenous triglyceride which is synthesized in the liver. So nag-carry sila ng triglyceride. They have a density of 0.95 to 1.006 kg per liter. So sabi ko kanina, they transport endogenous triglyceride from the liver pakadto sa muscle, fat depot, and in normal lipid metabolism, itong VLDL are secreted in the blood by the liver for metabolism in the peripheral tissues. So VLDL have apolipoproteins B100 mainly, and C1, C2, C3, and E under surface. Next. Next one is the HD. So that is the structure of the VLDL. So ito yung free cholesterol. So it consists of free cholesterol, may triglyceride din, then may esterified na cholesterol. Then kita nyo itong mga apolipoprotein. Ito siya. Apolipoprotein E, apolipoprotein B100, and apolipoprotein C. So always remember na ang each na lipoprotein kay naga-consist ng iba't ibang apolipoprotein. So baka maglabas yun sa quiz or what. So next. The next one is the HDL or high density lipoprotein or also known as alpha lipoprotein. This is also known as please comment down below. So, HDL is also known as high-density lipoprotein or alpha lipoprotein. So, meron pa siyang other name. So, please comment ko ano yun. So, attendance check. Please comment kung ano ang other name ng HDL aside from high-density lipoprotein and alpha lipoprotein. Yun. Tama. Good cholesterol. Tama kaan. Kagrupo mandaytaan. Good cholesterol. Okay? So, LDL is
Reply. Walang participation yung iba.
yun.
Participate class kaya ginap-check ko yung attendance yung class. Also, yung exercise sa kamay para hindi makatulog. Sige, just continue.
Okay. Thank you, guys. So, HDL is the smallest but the densest lipoprotein and has a density of 1.063 to 1.21 kg per liter. So HDL, saan siya ginasynthesize? In the liver and in the intestine. So HDL molecules are recycled siya na chylomicron and VLDL molecules. So in normal lipid metabolism, it performs reverse cholesterol transport. Again, ang HDL nag-perform ng reverse cholesterol transport. Kumbaga, HDL removes excess cholesterol from our peripheral tissues and transport it sa ating catabolic sites. So, this function has an anti-atherogenic effect. Kasi 'di ba, in atherosclerosis, there are build-up of fats, cholesterol, and other substances sa ating artery walls which nag-restrict ng flow. So yung HDL, it has the ability to remove those substances in the artery. So always remember that increased HDL is associated with decreased coronary artery. And if baba ang HDL mo, you are associated with increased na coronary artery disease. Okay, so kaya siya good cholesterol. So the CDC reference method is ultracentrifugation, precipitation with heparin, manganese, chloride, and Abel-Kendall assay, which is a method para ma-estimate ang total serum cholesterol level natin. And HDL has apolipoproteins of A1 mainly and A2 on its surface. Okay, so for its reference range, hindi namin siya gilagay kasi we want everyone to search on it and please comment it down. Reference range ng HDL. So please comment it down below. Reference range po ng HDL. May nag-comment na ba? Comment, guys. Guys. Okay. So, syempre, may ano yan siya. First is, tama yung sana yun? 60 mgdl. So, if ang person is protected against heart disease, ang kanyang HDL is greater than 60. So, meron dito, the higher the better. Yung the higher the better is 40 to 59. And if, yung risk ka if you have higher risk sa heart disease, your HDL is lesser than 40. Okay? So, protected ka sa heart disease if your HDL is greater than 60. Then, you have major risk sa heart disease if your HDL is lesser than 40. Yan. So, thank you for the comments. Okay, next. So, ito. So, this is the structure of the HDL. As you can see, may mga apolipoprotein siya. The A1, ito A1, the A2, the ApoE. So, it also consists of phospholipids, triglyceride, cholesterol ester, and free cholesterol. So, next. Okay, moving on. We have LDL, or low-density lipoprotein, or also known as bad cholesterol. So, it is synthesized in the liver and has a density of 1.019 to 1.063 kgdl. So LDL is the body's major cholesterol carrier and nag-transport siya ng large amount of endogenous cholesterol. So again, large amount of cholesterol. LDL is easily taken up by cells, so elevated levels are associated with increased risk ng atherosclerosis. So in normal lipid metabolism, this lipoprotein, which is the LDL, nag-bring siya ng cholesterol sa ating peripheral tissues for membrane synthesis and formation ng adrenal and reproductive hormones. So the apolipoproteins present sa LDL is ApoB100 and ApoE. So beta quantification, yan, is a method of lipoprotein measurement that uses ultracentrifugation to partially separate lipoprotein classes. This ultracentrifugation will be discussed more later. I-discuss din mamaya yung formula ng LDL, yung both Friedewald and DeLong's method. Okay, next. So this is the structure of the LDL. Lahat ng lipoprotein always remember they consist of phospholipid, esterified and esterified na cholesterol and triglyceride. Pero each lipoprotein may different yan siya na amount. So i-discuss ko din mamaya. And may apoprotein ito siya na B100. Ito yung main. Yan. Next. Okay, for the reference values for the LDL. If we say optimal, it is associated with lowest risk ng disease and mortality, which are atherosclerosis and coronary heart disease. Yan. Ito, near or above optimal, borderline, high, and very high. So, if we say very high, syempre, high ang risk mo sa atherosclerosis and coronary heart disease. So, delikado. Next. Okay, ito yung sabi ko kanina. So, for the chemical composition of lipoprotein, in each column, there are components, these are the components of lipoproteins, yan, the TAG, cholesterol, the phospholipid, and protein. And each rows, yan yung mga major classification ng lipoproteins. So, I want everyone to observe in the given table, yan, tingnan niyo muna, and please comment what type of lipoprotein has the highest level of triglyceride or triacid glycerol. So, anong lipoprotein ang may pinakamataas na level ng triglyceride? Okay, tama ka dyan. Chelsea, Ayan, Roxine, and Kedge, mga top 5 students, char. Okay, so tama. The kilomicrons. Okay, so end na. So yung kilomicrons have the, kung mapansin nyo, they have the lowest protein. Pero sila ang may pinakamataas na triglyceride. So how about the highest protein level? Please comment. Highest protein level. Wow, agtik si Jang, kagrupo man ta Jang. Yan, isya daw. Mga kagrupo man ako ni. Okay, si Crystal, Chelsea, and Minyao. Yes, HDL ang may pinakamataas na protein level. And kung ma-observe nyo, yung HDL din have the lowest level ng triglyceride. So, yun siya. So, yun lang. Next reporter, please.
Marinig ako, Len? Hello.
Opo, Jang.
Yeah, mag-start na ako. So, we have here the minor and abnormal lipoproteins. First, we have the IDL or the intermediate density lipoprotein. It results from loss of fatty acids from VLDL. So, product lang siya ng VLDL catabolism, meaning ano lang siya yung remnant. And then, it remains in the circulation or taken up by the liver via the LDL receptors. And then, ang IDL is somewhat similar to LDL because it transports a variety of triglyceride, fats, and cholesterols. And like LDL, it can also promote the growth of atheroma. Ang atheroma is yung abnormal accumulation of material in the inner layer of the wall of artery. So, bad cholesterol din siya, same ng LDL. Kay ang atheroma, it can cause the artery to harden and become narrow. Tapos, 'di ba, ang lipoproteins are divided according to their density and electrophoretic mobility. Ang sa IDL, ang kanyang electrophoretic mobility kay ano sa pre-beta or beta region. Tapos ang density niya is 1.006 to 1.019 kilogram per liter. So since lesser ang density niya sa potassium bromide solution, mag-float talaga siya, 'yon. Next. Hello. So yan, gi-explain naman yan kanina ang ano lang diyan, ang main point kay galing sa biosynthesis ng fats and cholesterols kay merong VLDL. Tapos after ng VLDL kay makatabolize yan siya that will yield to the remnant na IDL yan. Next. LPA or the lipoprotein A. It is an LDL-like particle kay parang same sila ng structure nung sa LDL. Tapos, it is proven to be pathogenic in nature and involved in the development of CDH. The increased levels of this lipoprotein may indicate premature coronary heart disease and stroke. It is also known as the sinking pre-beta lipoprotein. Tapos, yung similar sila sa ng VLDL in terms of electrophoretic mobility. The difference is that ang lipoprotein A kay naga-sink, ang VLDL kay naga-float. Tapos, it is isolated in the LDL-HDL density range by ultracentrifugation. And then, it contains APO beta 100 and density niya is 1.045 to 1.080 kilogram per liter. Next. Done. Yan ang structure ng lipoprotein A. Tapos, yung parang rainbow dyan, kaya yan siya yung mga wrinkles. And then, yung parang bilog dyan is the protease domain and the mga dyan, yung mga yellow gold na bilog-bilog kay phospholipids and then the blue ones are the free cholesterol. And then yung parang snake dyan kay yung APO beta 100. Next. Next is the lipoprotein X. Abnormal lipoprotein found in obstructive jaundice and LCAT deficiency. LCAT means lecithin cholesterol acyltransferase. So, ito ay in relation with lipoprotein metabolism. Tapos, in the serum of infants with persistent jaundice, it is an indicative of cholestasis. Ang cholestasis kay a liver disease caused by decrease in bile flow. Tapos, lipoprotein X contains mostly phospholipid and free cholesterol as well as ApoC and albumin. Next. Yan. Share ko lang. Next. Done. Yan, beta VLDL is also known as abnormally migrating beta VLDL. Abnormal siya because normally VLDL migrate in pre-beta region sa electrophoresis. Tapos, it has the density same with the VLDL. So, meaning mag-float pa rin siya because ang density niya is less than 1.006 kilogram per liter pala. Per liter. Next, done. Ay, wait lang. Sorry. It is richer in cholesterol content than VLDL. Tapos, sa picture nun. Ang beta VLDL in terms of sa electrophoresis, it co-migrates with the LDL, which explains that picture kay same di ba sila ng parang electrophoretic mobility. Yun lang. Thank you.
Hello? Hello, guys? Hello?
Yes.
Yes.
Away from sa lugar gani Mercado sa Tiboli.
Hello, guys? Kung naririnig
kauban
ako,
diri.
press A. Kung hindi, press B. Hello?
Kung narinig daw ang ating gold, yung maraming gold dyan, no? From Tiboli. Press A kung narinig. Kung press B naman kung hindi.
Hello, sir. Hello, guys. Dito ko mo pa naman. Wala ko may mabatian, pero mabasa na lang po.
Yan, marinig ka namin.
Wala man ko nakamute. Hindi man ko bungol.
Marinig ka namin.
Ay, ara na, sir. Ara na. So, for the lipoprotein methodologies, the preferred sample na ginagamit is the SST or the serum separating tube. Then, the sample for research studies is the EDTA or the EDTA to anticoagulated plasma. So, for the ultracentrifugation, ultracentrifugation is used to clarify lipemic samples in the chemistry lab as centrifugation at very high relative centrifugal force that will cause of large particles. Lipoproteins are separated based on electrophoresis and density. Next daw, liyog lang. Hello? Next daw. Okay. So, the reference method, ultracentrifugation is the reference method, and it is based on protein and triglyceride contents of lipoproteins. It is expressed in Sudbury units, and the reagent is the potassium bromide solution with 1.063 density. Next daw. Hello? So next is the electrophoresis method. So it allows electrophoresis method allows to separate in a quantitation of major lipoprotein classes as well as subclasses and provide a visual display useful in detecting unusual variant pattern. So sa electrophoresis, meron tayong HDL, VLDL, LDL, chylomicrons. Ito yung mga electrophoretic pattern natin, and VLDL migrates with the alpha-2 globulin or pre-beta. Agarose gel is the most common medium for separation of intact lipoproteins, providing a clear background and convenience in use. Okay? Okay na lang. Next. So next is the chemical precipitation. So chemical precipitation method is the process of conversion of a solution into solid by converting the substance into insoluble form or by making the solution a supersaturated one. So it usually uses with polyanions or such as heparin and divalent cation cations and polyethylene glycol. So, manganese or magnesium can be used to separate any of the lipoproteins, pero ang pinaka-common talaga na ginagamit is the HDL. So, beta quantification combines ultracentrifugation and chemical precipitation. It is the endoplasma. The sample is the endoplasma. Next po. So, next is the chromatographic method. Chromatographic method is based on the principle of separation or purification by chromatography, which is based on different absorption and unabsorbent. It it utilizes whether gel chromatography or affinity chromatography kasi yung gel chromatography is ginagamit siya to separate compounds such as small molecules, proteins, and polysaccharides, and marami pa. Ganon din sa affinity chromatography, nag-separate din siya ng mga biomolecule from a mixture. Next is the immunochemical method. Wala pa. Next is the immunochemical method. The specific proteins may be identified by immunochemical assays in which the reaction of the protein or antigen and is measured. So it uses antibodies specific to epitopes on the apolipoproteins. Next is the immunoassay or immunophilometry. It is a polypoprotein assay, and it is based on the measurement of the turbidity created by apolipoprotein antibody complexes. Next.
So next is the Friedwald method or indirect method. So cardiovascular risk stratification defines the LDL-C value target. Therefore, the LDL-C measurement technique requires standardization and good accuracy. So the Friedwald formula is an estimation of LDL-C level that uses the following levels of total cholesterol, triglycerides, and high-density lipoprotein cholesterol. Then, to be applied in the Friedwald formula, the measurements of total cholesterol, HDL-C, and TG or triglyceride must be in mg per dl. The estimation differs and was not performed for the millimole per liter measurements. So the Friedwald method became the standard method for LDL-C assessment because it is economical and simpler than direct assays. The most accurate LDL-C measurement method. So ang Friedwald method is the most accurate method siya for LDL or low density lipoprotein. So sa Friedwald method, indirect method, VLDL is times by VLDL millimoles per liter equals plasma triglycerides divided by 2.1755. VLDL naman sa mg per dl is equals to plasma triglycerides divided by 5.0. So next is the DeLong's method or indirect method. DeLong's method is a widely used test to compare the difference between two AUCs relies on the method developed in a seminal paper by DeLong. So it provides a confidence interval and standard error of the difference between two or more correlated AUCs. And then, may konting history ako about i-share sa DeLong. So, Elizabeth Ray DeLong is a statistician and professor at Duke University. In 1988, she published a test for determining whether the AUCs of two models are statistically significantly different. This test has come to be known as DeLong's test. So si Elizabeth Ray DeLong Kaya siya naging DeLong method kasi si Elizabeth Ray DeLong naging statistician or nag-create ng DeLong method. And then, to understand how DeLong's test works, we need to start with some notation. We will get used to this notation by using it to define sensitivity, specificity, and AUC. So DeLong method and direct method in VLDL, millimoles per liter equals plasma triglycerides divided by 2.825. Sa VLDL naman na mg per DL is equals to plasma triglyceride divided by 6.5. While sa sa low density lipoprotein equals total cholesterol minus HDL minus VLDL. So may ipa-solve ako guys. So dapat mag-solve.
Wait lang. Pwede ako magdagdag?
Ay, sige lang.
So, yung Friedewald method is not valid for triglycerides over 400 mgdl. So, again, yung Friedewald, hindi siya ginagamit if yung triglyceride level mo is over 400 mgdl. So, if maglapa siya, ang gamitin mo is DeLong's method. So, yun lang.
So, may ipa-solve ako guys. Maglagay ako ng equation then isolve nyo. Wait. About siya sa guys, sa Friedewald method. Tas after nyo mag-solve guys is ilagay nyo kung ang reference value ng LDL niya, kung high ba siya or normal ba yung niya reference value or borderline value or very high ang kanyang lower density lipoprotein. Using the Friedewald method.
Nalagay mo ang answer.
Ano lagay ko?
Another question na lang.
Ano lagay ko pa? Ay, wala man Len. Tama man Len.
Mga classmates mo.
Yan, sir.
Kuan gano ang kita ko niya ke. Hindi mo kuan di na ni gamiton, di mo ulan. Di ni gamiton.
sa formula. Yung presentation ninyo. May nag-request dito, pabalik doon sa formula. O, yan.
Don,
Crystal,
pa-present
you
na
can
ulit.
also show the Crystal, you can also show the formula or paano mo i-compute sa group, ha? Okay, so there are also computations class, ha, in our examination, how to compute.
Tama po si Ayan, sir. Si Ayan at
Okay,
saka
so
si Gades.
you can show your solution to the group.
Sir?
Show your solution to the group. Ilagay sa bond paper at saka i-flash sa screen.
Sige po, sir. Wait lang po, sir.
Makita nyo, guys?
And my teacher si Lenny.
Opo.
So, ito yun siya yung question kanina. So, dapat, pag mag-Friday wall, di ba dapat ang hanapin talaga yung LDL per na-mention ng, yung ano, ayan. So, ito siya. Total cholesterol is 242. The TH is 204 ml. HDL is 40 mgdl. And then yung LDL, para makuha yung LDL ito, total cholesterol plus ito siya na equation. So, dapat hindi ibigay yung LDL kay para may pagod, mahaba pa ang pag-solve. Okay. Ikaw na, Kay.
Okay. Sige. Okay, thank you so much, reporter. So may mga questions pa ba, class? Wala na. Okay, so I think it's time na sa lecture, no? So we will have a break first, then balik lang kayo agad mamaya mga 10, okay? 10 p.m. balik tayo class for hour. Another lecture na aking i-discuss sa inyo. Okay? So we'll be creating another link class, no, para yung iba na hindi makapasok dito, makapasok na naman sila. Okay, so kung may mga questions pa, bakit yung iba wala laging sagot ang iba? Hindi ba sila nag-participate? So, maskin mangupya na lang sa mga classmates na wala dyan. So, alam niyo ba, class, ilan na ang nagsagot? Nasa 10 lang. So, meaning, ano yung ginagawa ng iba? Hindi nag-participate yung iba. Sulat ko ba, class, ang mga nag-participate? Pabalik-balik lang ang mga names nila. Out of 25 na participants, bakit nasa 10 lang ang nag-participate? Saan yung iba? So, hindi excuse class, ha? Hindi excuse na kahit nasa online lang tayo, hindi tayo mag-participate. Please participate naman. Kasi class, sa board exam, lumalabas talaga itong mga questions na to. Especially the computations, no? Yung mga computations na to. So, I'm very good reporters kasi lahat ng mga dapat nating malaman na share ninyo. But don't you worry, sa mga hindi pa nakagets, I will be sharing to you later on another inputs, no, sa ating mga reporters. Yan. Sige, bakit yung iba wala? Okay, so anyway, okay, so we'll have a break first. Balik kayo class ha, 10 a.m. Okay, 10 a.m. for our laboratory. Okay, so thank you so much and God bless us all. I will end this. I'll be creating another one.